Most people are finishing up. A few more seconds. DePaul? Yes, you can. All right, so the title of this page was Linear Inequalities. Remember that a linear inequality is a statements which have an inequality symbol. You're filling in inequality symbol here. Inequality symbol. And remember, that is these things. Remember, the ones that point to the left have less in them. So this is less than, greater than. Less than or equal to, greater than or equal to. Linear inequalities are solved. Anybody remember how we solve linear inequalities? By graphing. So steps for graphing. What form do we write the inequality in before we graph? Anybody remember? Paul, you remember? What's the form we write the inequality in? The one that's easiest to graph from. What do we call that one? Slope-intercept form.
Yeah.
Remember, that's normally if it's an equation, it's y equals mx plus b. If it's an inequality, it's going to be y. One of the inequalities, mx plus b, right? We want to be able to plot the y-intercept and then use the slope to find more points. So when we graph the inequality, we're really graphing the line. It's just the boundary of that. So, but we're graphing by plotting the y-intercept and then using the slope. So remember though, we use a solid line for the inequalities that have an or equal to under them. So less than or equal to or greater than or equal to. And those, all the points on those lines are included in our solution. So we're going to say points on the line are included in the solution.
What they say? Points on the line.
Points on the line are included, I abbreviated included, in the solution. That word's a little hard to read there, I think. Now when we're graphing the boundary or the line on the coordinate plane, if it's a less than or greater than, remember, it's a dotted line. And the points on the line now are not part of the solution. Are not included in the solution. But remember, graphing that line or the boundary is only the beginning. The solution to an inequality is the points that are shaded. So we have to know which part to shade. So, below 3 here, we shade above the line for the greater than or equal to. below the line for less than or equal to. Remember when we say shade below, you put your pencil on the line and pull up if you're shading up. You put your pencil on the line and you pull down if you're shading down. Because it can be a little bit confusing up and down on the coordinate plane since it's an infinite space. And last but not least, I've already said it, but the solutions for the inequality are all the shaded points on the coordinate plane, or all the points in the shaded region of the coordinate plane. So this is all review. This is what we did Thursday and Friday. If you were here Friday, I believe we did every single problem on your homework together except for one. Right. Catch is, you guys don't get any credit for incomplete work, right? So literally you had one problem for homework last week, or last Friday, so I'm hoping we had a better percentage of completion than our average day. From my recollection, unless you all turned it in this morning before 7:30, probably not much better, even though we did the whole thing together. I imagine that you're finding you're falling farther and farther behind if you're not doing your homework, not getting your practice. And I hate that. There's just not any way around it. I wish that I could teach this subject to you without requiring you to practice it. But there's not another way. There's just not a way. It's like teaching you a sport, or how to play an instrument, or how to speak a language, or any other creative thing without you practicing it, right? So if you don't practice, it's going to be impossible. Right, so today we're learning about systems of inequalities, and I actually don't like that. Let's just put, let's just cross that out. Just write systems of inequalities. So a system of equations is two or more equations that have the same variable, if you recall. So anybody want to take a guess at what a system of inequalities is? Taj, take your earpods out for me, bud. Thank you. Two or more inequalities with the same variables. Just like a system of equations, there's two or more equations with the same variable. So any of the, if they're the same variable as x or y, y or z, b or c, whatever they are, that means it would have the same value in both inequalities. So a system of inequalities is two or more inequalities which have the same variables. So to solve a system of inequalities, we're going to do the same thing we did to solve a system of equations. We're going to graph that system, or graph each of the equations that are part of that system on the coordinate plane. That's what we did for a system of equations. For a system of inequalities, is there two there? There's only one. You can get another one off, and I'll come back and pick it up. You take another one off of there? Alright, so, to solve a system of inequalities, all we do is graph both inequalities on the same coordinate plane. Which means we graph the boundary, then we shade. We graph the boundary, and then we shade. Did you get another one? Well, I think that's two. Would you check it? I think that's two. Would you check? Alright, so the solution to the system is the part of the coordinate plane where the shading overlaps. So we're about to do a couple of examples. Did you forget something? I haven't seen it. So I think I've given everybody two coordinate planes. We're going to put these in our notes in a second. You want to make sure? I think there's two there. They're pretty thin. Only one? Okay, so we're going to do two examples. You only have 6 problems on your homework. I'm not opposed to doing some of your homework problems with you, but we're going to start with 2 problems that are not on your homework. So we're going to start with number 1. First, write the directions, and then write example 1. Yes, the ball.
I need some coordinates.
What's that?
I need
Oh, you didn't give me. No, that's your homework. This are going to be for your notes. So the 2 coordinate plane stickers that I gave you, you're going to be putting in your notes. One of them's for this problem, but don't put it in there yet. Go ahead and write the problem. And then for this one, these inequalities are already solved for y. They're already in slope-intercept form. So once you write the system of inequalities, you can go ahead and put your sticker for the coordinate plane right below it. But write the system first. So you write an example 1 first, and then put the sticker under it. Where are the rest of your notes, Jay? Write this direction in that first example. Can you see? So this is a system of inequalities. It's 2 inequalities. Remember, inequalities are statements that have an inequality symbol in them. linear inequalities like we have linear equations. So, our directions say we're just going to graph each of these inequalities on this same coordinate plane. So we're going to start by graphing the first inequality. So to graph the first inequality, we're going to start by plotting its y-intercept. What is the y-intercept for that first inequality? Jalen, can you tell me the y-intercept? No? So, DePaul?
-1.
Very good. So remember, slope-intercept form in this case is going to look like this. Remember that b is your y-intercept, the constant is your y-intercept. The y-intercept is the point on the y-axis where the line crosses. So it's -1. So we're plotting that first. Now what is the slope of this first inequality? Jalen? 2. That's right. Now when we use the slope though, we need it in rise over run form. So we're going to stick it over 1. And remember, this is going to take us up and to the right because it's positive and positive. But we want to be able to go down and to the left too, down to this other quadrant. So we can write this. Yes, very good, Aiden. Both negatives. So let's go ahead and plot the points using up to the right one, all the way off our coordinate plane, and then we'll go down to the left one. And now we have to remember, is this going to be a solid or a dotted line?
Solid.
Very good. If it's an or equal to inequality, it's always a solid line. But we're not done. Remember, this is just graphing the boundary. Now I'm going to shade either above it or below it.
That's
Okay.
shade
So are
down.
we going to shade above it or below it?
Below it. Wait.
Yes, that's
Yeah.
right. You're right. Don't second guess yourself. That's right. Less than or equal to. You look at your notes from today. We recap these notes. That's the less than. So put your pencil on the line and pull down. And shade this really lightly because we're about to do another line. Remember we just said that the solution to the entire system will be where all the shading overlaps. So you don't want to do your first shading very dark because it's easier to tell where the solution is if you do them both very lightly, and then when you overlap, that'll be the darker part. Alright, so that we have graphed the first inequality. So graphing that first inequality doesn't mean just graphing the boundary, it means graphing it and shading it. Jalen, what's the y-intercept of the second inequality? Very good. So the second inequality, the y-intercept is 3. That's where we start graphing. So we're going to go up 3 on the y-axis. What is the slope of that second inequality? Caleb Berry? A little bit tricky. Say it again? Very good. It's a little bit tricky because you don't see it there. It's just a negative sign. Remember, we're going to write it as a fraction. And then we're going to flop them because we want to be able to go both ways. So +1 and -1. Those are equivalent fractions. We can use any fraction that's equivalent to our slope. So that's supposed to be on your notes, right? That's supposed to be on your notes. Your coordinate plane should be stuck to your notes now. Caleb Berry, go ahead and stick it on under the system where we're working. Stick it under the system because you're going to have to graph that as part of your notes. Alright, so down 1 and to the right one. Down 1 and to the right one. Going to do that until we run off the edge of the coordinate plane, and then we're going to go the other way. We're going to go up 1 and to the left one until we run off the edge of the coordinate plane. Is this line going to be solid or dotted?
Solid.
Solid, because it's got an or equal to underneath there. Now, does this one get shaded up or down? coordinate plane, so any point in this section, and any point on either line from here up or here down, that is part of our solution. So if we're picking a specific solution out of this point, I'm going to say I'm going to say 5, 1, 1, 2, 3, 4, 5. Over 5 and up 1, that is a specific. So 5, 1 is a particular or a specific solution. That's just one of an infinite number of solutions from this system of inequalities. Any questions? Does that make sense, Anaya? This is actually our last section before we take another test. We will review for a couple days. Does that make sense, Maria? Does that make sense, Jason? No, Jason. Jacob? That makes Shamar, you awake, buddy? That's what I feared. Sydney, you awake? Okay. Petty? No, you don't actually, right? Because we're about to do our second example, and you haven't done the first. All right, so our second inequality. Don't put your sticker on this one yet, because these have to be solved for y first. These two inequalities both have to be written in slope-intercept form before we can start graphing on our coordinate plane. So don't stick your sticky to your notes yet. Go ahead and write example 2. 3x minus 2y is less than or equal to 4. X plus 3y is less than or equal to 6. We can never graph an inequality unless it's solved for y, unless the y is isolated by itself, because sometimes it's going to split that inequality. So we're going to start by now rewriting this first inequality and solving it for y. 3x minus 2y is less than or equal to 4. We should be able to move everything away from that y at this point. We need to get the 3x over there, and then we need to get the negative 2. We're going to always undo that 3x. This is a positive 3x, we're going to subtract 3x. Not just 3, not just x, but the 3x. So that leaves us with negative 2 times y is less than or equal to negative 3x plus 4. And we want this in slope-intercept form. So for this particular inequality, the y, some inequality symbol, mx plus b. It does not matter which inequality symbol is there, but we need the y isolated. So this one is tricky. You have to remember back to when you first learned about solving inequalities in middle school. We're dividing everything by negative 2 to get the y by itself. We have to remember, I know DePaul remembered this first thing last week.
Well,
What happens when we divide that y by negative? It makes that inequality flip, right? So now instead of a less than or equal to, it's a greater than or equal to. Negative divided by negative, it changes to a positive. 3 has x. And then 4 divided by negative 2 is minus 2.
yeah.
So that is going to be our first inequality. But before we graph that, we're going to go ahead and solve our other inequality for y as well. Put it in slope-intercept form as well. x, so we subtract x. That leaves us 3y is less than or equal to the opposite of x plus
Negative
6,
x.
or you guys all usually say negative x. Drag that coordinate plane away, so I'm not ready for it. The y is not by itself yet, so I divide everything by positive 3. Now because we're dividing by positive, we do not flip that inequality, remember? So that's going to stay a less than or equal to. If you don't see that, that's a 1. So I'm going to rewrite that as negative 1/3 x. 6 divided by 3 is positive 2. So that is our second inequality that we will be graphing as part of our system. Same two inequalities, just written in a different form. And they have to be in this form in order for us to graph them. You may think, well, we learned how to graph with x and y intercepts, but we do not want to use that strategy because sometimes the inequality symbol has to flip.
I
DePaul?
got a question.
Okay.
So you ain't flip it because the 3y was a negative, right?
Because the 3 was a positive, right?
Oh, alright.
Yeah. Anytime if you're isolating something in an inequality, anytime you multiply or divide a variable by negative, then you're going to flip that inequality symbol.
If
Right?
it's positive, keep it.
So because this was positive, we keep it. That's right.
So,
All right, so now we're going to go ahead and graph the first inequality. What's the y-intercept for this first inequality, Aiden? Negative 2, very good. So we're going to go down here, 2 on our negative 2 on our coordinate plane is in a big dot. And now our slope for that one?
3/2.
Very good. It's a positive 3/2. So the slope here is already in rise over run form.
On both negatives.
And we're going to go ahead and do both of them because we want to make sure we have a good, nice, neat boundary all the way across our coordinate plane. So we're going to go up 1, 2, 3, and over 2 until we get off of our coordinate plane, all the way to the edges. 1, 2, 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. And then we're going to go down 3 and to the left 2. Now this first one is going to be a solid or a dotted line.
solid.
Yeah, if it's got a solid line under it, it's a solid line. So that's right. It's going to be a solid line. It's going to be a solid line. Now, we have not graphed it until we shaded it. Is this going to be shaded up or down?
Up.
How do you know it's shaded up, DePaul?
Notes.
Sorry?
That's what the notes say.
Very good. Greater than. Pointing to the right, we shade up. So the notes say it. I'm going to go with what our notes say. I'm going to do that one yellow. So we're going to go up. So, you might think, oh, well, this is up, right? This and this are both up. Well, we're not shading there and there. Put your pencil on your line and shade up. Really lightly, because remember on these, the part where they overlap is the part that's part of the solution. All right, so what is the y-intercept for our second inequality? What is the y-intercept for our second inequality, Sam?
Hi.
Hey.
I'm in yearbook. I was wondering if I could take photos.
Sure.
Thank you.
The second inequality, Sam. Plus 2, positive 2. So positive 2 on the y-axis, 1, 2. Now, what is the slope of this second inequality? Faith, what's the slope of this second inequality? Very good. Negative 1 over positive 3. But remember, we could also do it as positive 1 over negative 3. And we're going to use both of those different forms so we can get points that go all the way across our coordinate plane. So we'll always start from that point on the y-axis, use our other,
Thank you, Miss Zimmerman.
you're welcome. We can use our other form. Go up 1 and to the left. 1, 2, 3. Up 1 to the left. 1, 2, 3. I think that's, see here. Oh, there it is. I couldn't see that other point. And this is also going to be a solid line. So I'm going to draw my line through those points. Do you know which way we're going to shade it, Shori?
Down, up.
We are going to shade it down or up. Can you narrow it down for me a little bit?
Yeah, that's what up. Down.
Yes, very good. Down. Less than or equal to is down. Put your pencil on the line.
Don't think of it.
Oh, thank the Lord. You had a 50-50 shot. All right, so I'd like to see your shading all the way under this line, and then I'd like for you to darken the part where they overlap. So here, this is the part where they overlap. It does work really nicely if you have different color highlighters or colored pencils. So if we're picking a particular solution, so a specific solution for this system of inequalities, any point in here. So I'm going to pick this one. So it's left 1, 2, 3, 4, -4, +1. But remember, there's an infinite number of solutions. So it would be in that shaded area. Remember that shaded area goes on forever and ever. These lines extend forever and ever, and everything that falls within those lines are a solution. Another solution would be 0, 2. Because the points on the solid lines are also solutions to the system.
Do you always have to write the solution?
No, that is going to be probably a question of the test. They're going to ask you either to give a specific solution from that system, or they're going to ask you a particular point is a solution. So if they do that, that's when we plug in the coordinates to the system. And we have to work in both inequalities for a system. Any other questions?
No.
All right, I'll give you guys time to finish that, and then we'll start working on your homework together if you like. We should be able to do at least one of them. You only have 6 problems. So we'll do a couple of them together, hopefully one, at least one, maybe 2. I don't actually remember which one it is on here. I'm looking to see. Who's yours? Yeah. All right, so number 1. Let's go ahead and do number 1 together. If you're talking, let's stop. I'm trying to help you get some homework done. So number 1, this is the worksheet for your assignment tonight. So we're going to do number 1 together. Number 1 is already solved for y. Woohoo! Are there any on this assignment that aren't solved for y? Let's see.
Number 8.
We'll do number 4. Why number 4? Why does number 4 look weird to you? Oh, because it's got a fraction in it? Oh, it's got a y only? Sure, we'll do number 4. We'll do number 4 first instead of number 1. I don't mind which one we do. You do need to be able to do these on your own. This is a good one to do if you're uncomfortable with it to start with. See if I can get it to scroll. See if I can get it bigger. Okay. So this is one of the special lines, right? Is that a horizontal or a vertical line? Remember, think Hoy and Bucks. It's a Bucks, right? So it's a vertical line through this number on the x-axis. So we're going to put a point on the x-axis at -3. line through that point. Is it a solid or a dotted line? Very good, it's a solid. Now this one's a little bit weird. Which way does this one get shaded? Very good. It's pointing to the left. That's the way it gets shaded. This is the only one that's a little bit, oh, what's that color from?
Oh,
This one is a little, it doesn't follow the up or down rule, right?
yeah.
But this one makes sense. Because if it's less than -3, it's going to be everything to the left. Alright, so now we need to be able to graph the second inequality. +2 is the y-intercept. What's the slope, Sam? What's the slope for this line? So that's the y-intercept. Yeah, 5/3, so that means we're going to go up 5 and down 3, but we can't go up 5, right? So we could do it what? -3, right? So down 5, left 3. Yes, Aiden?
Wouldn't it just be a dotted line? Because it has no line or anything.
Yes, very good. It is going to be a dotted line. Let's put our points next, and then we'll put a dotted line. So down 1, 2, 3, 4, 5, and to the left 3. 1, 2, 3. And that's, we can only get 2 points here. So this one is a dotted line. It's a very good line. Let's try again. That's a little bit better. I would expect you to use a straight edge. I don't want any old ugly lines. Alright, so this is shaded up or down, Jeremiah? Nope, it's pointing to the left, right? Down. So, put my pencil on the line and pull down. Where does this one overlap? It's a very tiny space where this one overlaps. Do you see where it overlaps?
Yes.
I need a really fine point here. It only overlaps right here. This is where the shading overlaps. So I gotta see. There's a space right here. Well, it seems like, what the heck was that, boy? But remember, this goes on forever, right? So that space, that section is going to get bigger and bigger. But on our coordinate plane, it only looks like that. There you go. Just in case no one else thought that was funny the first time.
It really wasn't.
-5, which one? Probably, oh, this, I think this is -4 here. So let's say -4 down 1, 2, 3, 4, 5. Well, that might be on the line, but if you said -6, I think we're pretty safe. Okay? It's going to be off our coordinate plane. Alright, does that make sense? You want to do one more, then you only have 4 for homework? You want to do on your own then?
Yeah.
Alright, so go ahead and get started. If someone would like me to do another one with you, let me know. We'll do one.
So you did number one.
Number 1 it is.
What's the
Everybody's working now, though. If you say you don't want me to do it, that means you're doing it on your own. That does not mean you're packing up. Alright, number 1, yay. They're already in slope-intercept form. Wasim, what do I plot first in the first inequality? What do I plot first in that first inequality? Yep, -2 on the y-axis. What's the slope of that line, Wasim? Yeah, -1/1, or we're going to do +1 over -1. So down 1 to the right 1. And then we're going to go up 1 to the left 1, all the way off the coordinate plane to the very edges. Got a line underneath it, so is it going to be a solid or a dotted line?
solid?
Good. Oh. Which way am I gonna shade it, up or down? That's how you tell, right? Down, that's right, you're gonna shade it down. Put your pencil on the line and shade down. Now we're shading the, graphing the other line. What do we do first to graph the other line, Tyrese, do you know? Will Aiden help you? Okay, Aiden.
You put the positive 2 right here.
Put the positive 2 on the y-axis. So point on positive 2 on the y-axis, that's right.
And then the m would be negative 5 over 1.
Very good.
And then you can switch them around.
Right.
Positive 5 and negative 1.
Perfect.
And then you apply.
So, yeah, because we can go, actually we can't go up 5, so we're just gonna do the down 5. 1, 2, 3, 4, 5, into the right one. Really can only get 2 points. Solid or dotted line?
Solid.
Yes,
Dot.
because there's a line underneath there. So if you guys are still struggling with how to graph these lines, I want to be able to help you, but you're probably going to have to come see me some other time or other when we're learning new stuff in class, and that's something that's not new. I'm not saying you can't learn it, you can, but you're going to have to make an effort because we're using old stuff that some of you are not comfortable with right now. And we're going to shade this one up. So put my pencil, so up and up. This is not the up we want. It's going to be pulling up on this side. My line did not go all the way. So this one, it's overlapped. We see you ready? Alright? That little bitty part right there is the only part where they overlap. Ready? You have 4 questions to do. Only 4. Don't forget to submit your notes. I'm going to double check as soon as I sit down in my chair and make sure I have an assignment for those notes.
Get up.
And I will post the recording.